Let's give a warm welcome to Mr. Deepak Puranik. Mr. Puranik is National Sales Head of Strategic Business, India and Sri Lanka at AAF India. He has been instrumental in supplementing IAQ solutions in many corporates. Coming from mechanical engineering background, Mr. Puranik is an MBA from BITS Pilani. For the last 2 decades, Mr. Puranik is associated with building industry in India. His domain areas have been HVAC, building automation, indoor air quality, and air filtration. He also holds a diploma in psychology and also imparts corporate training. Today, Mr. Puranik will share his insights on indoor air quality in commercial spaces. So please welcome Mr. Deepak Puranik.
Yeah, thank you, Darshana. Thank you so much for that introduction. So, I'm going to talk about the aspects of indoor air quality in commercial buildings. We'll touch on the importance of indoor air quality, the impact, and the possible challenges that we come across to maintain good indoor air quality. So, the agenda of this quick talk of 10 minutes is to understand what is indoor air quality, what are the air filtration standards, what are the possible business implications of poor indoor air quality, and what are the challenges, and then how can a good expert can help uh, in attaining good indoor air quality in any commercial space. So let's understand what is indoor air quality. So generally, indoor air quality is viewed and perceived with differently by different individuals based on what they see, what they smell, what they feel. But it's important to have uh, uh, the technical view towards indoor air quality. So indoor air quality is definitely refers to air quality within the building, and that is contributed by the parameters like the level of pollutants that present in that indoor air quality. And it's often seen that if indoor space is not maintained the way it needs to be, then the indoor uh, spaces are 5 times more polluted than the outdoor spaces. And what are those possible indoor air pollutants? And those could be the particulate matters, dust, ash, molds, pollen, bacteria, virus, etc. And then there is another type of pollutants. Those are gaseous pollutants, which include the volatile organic compounds, ozone, hydrogen sulfide, NOx, SOx, ammonia, such pollutants. So, having understood what are those pollutants and then uh, what is indoor air quality, and to define indoor air quality, there are standard organizations like WHO, well, OSHA, and few more have kind of defined what should be the threshold levels of those parameters that we consider as pollutants. So these are the few examples of the parameters that are that are measured and monitored to maintain the good indoor air quality within occupied spaces. And the numbers that you see and the units that you see are the one which are the which are the threshold levels guided by the respective uh, 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 standard organization. And this is the picture that you see is a human lung, and it's evident that as you as you as the smaller the dust particle is the more harmful for human health. Now you see if the dust particle is less than 1 micron, that eventually gets into alveoli of human lung and gets into bloodstream. So that is this is the most dangerous uh, uh, size of dust particle, and this is what eventually cause the disease like cardiovascular disease, asthma, the eyes and nose, throat irritation, spas, and things like that. So, having understood what is indoor air quality, what are the different parameters contribute to indoor air quality, what should be the threshold level, So it's really important. I mean, we often see that this is the ignored topic. One, because it's not visible. Second, because people often don't see the business implication of poor indoor air quality. And the reason I'm talking about business implication, because we all go to business establishments to work, and we spend most of our time in those indoor spaces. So it's very important to make the business heads, the CEOs or the business owners to realize how important is indoor air quality and what are the possible implications of poor indoor air quality. Now, because of indoor air quality, there could be many problems that may arise in the occupants area. It could be health, it could be sick building syndrome, odor, energy consequences, the equipment corrosion because of the corrosive environment, the challenges of meeting the environmental norms, and of course, you have a neighbors to take care. So the implication of these problems could be many and to the large scale. So the immediate implication is poor employee experience, and that would result to low employee productivity. Then that eventually results into financial losses. And what is this number? What is this value? What is this uh, impact? Is something, depends on building to building, business to business. So it's important to make people realize how poor indoor air quality impacts their businesses, so that there is a inclination, uh, driven to invest in good indoor air quality. And this is a result of one of the research that was done in Harvard Business School, which shows how good indoor air quality um, increases the ability to respond during crisis, how indoor air quality influences usage of information, and then how does it influence the strategy making ability. Having understood what is indoor air quality, how does it really impact the business, what are the problems, what are the implications. So let's understand something basic, uh, the technical side of indoor air quality, that is the air filtration standards. Now, there are three prevalent air filtration standards that exist. One is ASHRAE 52.2, which is the American standard. Then is EN 779, which is a European standard. And then there's the ISO standard, ISO 16890. So, the most recent standard that was introduced is ISO 16890, with the intention that ASHRAE 52.2 and EN 779 would be discontinued, but that hasn't happened in the practical world. People still talk about ASHRAE, EN, and they also talk about ISO 16890. So these standards basically have been derived based on the efficiency those filters exhibit when they are tested. Uh, so I'll just take quickly two examples how these are categorized. So, for example, if we have to look at MERV 8 filter in ASHRAE 52.2, this is the filter which exhibits 70% efficiency for the dust particle of size 3 to 10 micron, 20% efficiency for the dust particle of size 1 to 3 micron. Now, if you take next example, MERV 13, it's a filter that exhibits 90% efficiency for dust size 3 to 10 micron, 80% efficiency for the dust size of 1 to 3 micron, and then 35% efficiency, 50% efficiency for the dust size of zero point 0.3 to 1 micron. Similarly, in 779, these are classified under coarse, medium, and fine filter. The classification starts from G1 to F9, and these are the efficiencies that they are classified by. In ISO 16890, there are four major classification: ISO course PM10, EPM 2.5, and EPM 1. 1, 2.5, 10 are the size of dust particles: 10 micron, 2.5 micron, and 1 micron. And for the benefit of Indian market specifically, where people, the consultants, the architects, the owners, the contractors, they talk in all three standards. So there is a correlation that is derived. Again, I'll take two examples. MERV 8 is equivalent to G4 in EN 779 is equivalent to 90% efficiency ISO course, and MERV 13 is equivalent to F7 is equivalent to any of these three ISO standards. So, in one of the previous discussion, I was talking about the scientific methodology to select the right filter, and this is the methodology. Will not go in detail. However, I'll just touch on the surface. When to select the filter, it's important to understand the outdoor air quality. So, outdoor air quality is categorized under outdoor air quality 1, 2, and 3 based on the WHO standard. OAQ 1 is the cleanest environment, OAQ 2 is moderately polluted, and OAQ 3 is heavily polluted. Then it's important to see the supply air categories, which is classified under the range supplier 1, 2, 3, 4, and 5. 1 is the most hygiene requirement of supplier, and then 5 is the lowest hygiene requirement. And the supplier quality and outdoor air quality are mapped in this matrix. For example, if you are coming up with uh, a mall, shopping mall in city center in Delhi, then how do you select the filter? So we know city center uh, in Delhi, it is classified under OAQ 3 or ODA 3, and then the shopping malls are classified under supplier 3. So then we would look at this matrix and then map ODA 3 and then supplier 3 in this matrix. So we arrive at 80% EPM 2.5 filter. So this should be the final stage filter. And this, to protect this filter, there has to be pre and fine filters that need to be worked upon. So this is the simple and basic methodology to select the right filter for the building. So having selected the performance efficient filter, it's also important to look at the energy that is consumed by the filter. So, to all the designers, all people, all those who are looking at the replacing the filters, upgrading the filters in their building, it's important to know what kind of energy filters consume. Now, if you look at this red line, you can see the the energy that is consumed by the bottommost red line is EPM 10 50% filter consumes around 850 kilowatt hour. EPM 2. EPM 2.5 60% efficiency consumes around 1500 kWh in a year, and EPM 170% consumes almost 1700 kWh per year. That means I'm just giving a relevance. How does it reflect into the money that you spend? So typically, 1 lakh square feet building would consume uh, around 29 to 30 lakhs when it's in relevance to the filtration. So it's very important whether the right selection of filter could increase this number from 30 lakhs to 40 lakhs, or you reduce it from 30 lakhs to 25 lakhs or 20 lakhs. So selection of filter, keeping the energy consumption of those filters is very important. So this is one of the option, how you balance between the efficiency of the filters and energy consumption of the filter. So I'll just read the inference of this research and study that is done. So it says with 14% higher expenses in operation cost and capital cost of the filter, you will be protecting or will be you'll be protecting people from 82% of the potent contagious particle every day. So it's very important, again, very important aspect for the designers to consider. Someone interested can definitely connect with us and then can share uh, more details. And these are the few flagship products that are used in market, the AF products. This is typically uh, viewed as a pre-filters G4 grade equivalent to MER rate equivalent to 460%. This is uh, V-Bank filter F7 grade MERV 13 EPM 2.5 67% and PM 1 50% filter. F9 MERV 15 equivalent to EPM 1 85% filter. Uh, Earlier in this presentation, we spoke about the gaseous contaminants. The mechanical filters do not filter the gaseous contaminants. So to remove the gaseous contaminants, there's something called gas phase filters, uh, uh, often known as activated carbon and activated alumina. So based on the contamination, these come in the form of granules. So uh, these are chemically coated based on the kind of gaseous contaminants that need to be removed and used in the various equipment that are seen on the slide based on the concentration that needs to be removed. The type of equipment will be used. So, how can knowing what kind of pollution, what kind of threshold to be maintained, what kind of guarantees, guidelines to be followed, how can the indoor air quality experts can help? So that's something interesting need to look at. So this also connects to the best practices question that Mr. Gopal Krishna asked earlier in this session. So the best practices can start about having awareness programs for uh, the organizations for and for the individuals, and then there can be site survey and the reports which can include the benchmark and also various other analysis that connects to energy and total cost of ownership, etc. And then comes the solution. Then what kind of solution that can be had to serve the purpose and the reason why you want to go for indoor air quality. It can be for health reason, it can be for process, or it can be for environment reasons. So this is one of the new trend that people are looking for, IQS service, which includes the end-to-end management of indoor air quality, where the expert would completely manage the indoor air quality, bring in clarity into the indoor air quality, make the invisible visible, that there would be 24/7 indoor air quality monitoring uh, uh, facility would be provided, and there will be commitment to indoor air quality. So it's more of a performance-based contract for indoor air quality. So with this, it would be kind of OPEX-based model charged per square feet per month, and the days and the month when the committed parameters of indoor air quality are not managed, then that day and month will not be charged. Very interesting model to explore. So this is the technology to monitor indoor air quality. There will be sensors, indoor air quality sensor, outdoor air quality sensors, DP sensors connected to the gateway and to the cloud, and then from cloud you can obviously download an app where you would see the various parameters that would help you to have the insights of indoor air quality, energy usage by the filters, remaining life span of the filters, the TCO of the equipment that you have invested in for the indoor to achieve indoor air quality. All this can be viewed, and then you can also display the indoor air quality parameters and outdoor air quality parameters on the smart watch. So such provisions are also available. So obviously, speaking about air quality, the filtration plays a major role, and the type of filters and standard used become much more important. So it's all about the integrity the solution provider follows and the product manufacturer follows. So there are technology available. The companies have invested. AF has invested in those technologies to test the filters. So this is a kind of called auto scanner, where there is you test the filters without any manual intervention as per EN 182 standard. And AF is the only company who has currently this facility available in India. For ISO 16890, AF has this facility, but in Malaysia facility. So when we talk about selecting the right equipment, so there is definitely a selection criteria on the equipment. So the capacity of equipment that could be chosen. Very basic formula. So all HVAC professionals would know about this. The facility management facilities professionals would know about this. So when you are when you're using the equipment at 6 ACPH, the thumb rule 1 square feet is 1 CFM. So, when you change the ACPH, then there's a basic formula that is used: volume into ACPH divided by 60 is CFM. That's how you select the equipment. So AF offers wide range of equipment to support the indoor air quality goals of various type of buildings, various type of businesses. So starting from the basic
Hello.
particulate matter filters to, so this is the chemical media. We have ceiling suspended units. We have floor mounted units. We have recirculation units. We have cassette type air separation units. So various solutions that we can bring on. Right. So with that, let me close the presentation, uh, sharing that we connect to uh, around 5 SDGs, 4 to 5 SDGs when we extend our services towards indoor air quality.